All right, next you were asked to go through for a tetrahedral complex and do D0 through the D10 electron configurations. Well, the first thing to get down is so we've always been talking about thus far the octahedral. And for those, there's a T2G set on the bottom and an EG set on the top. For tetrahedral, it gets switched. We have an E, just E by itself, set on the bottom, and what's called a T2 set on the top. Also, this delta tet is small. It's small for basically any metal and any ligand set. This is always really, really small. And so there's no such thing as low spin tetrahedral. Okay, no such thing as low spin tetrahedral. Because this gap is so small, it always is energetically a better deal to go to the top than it is to start pairing in the bottom. So there's essentially never low spin tetrahedral. All right, so what I want you to do is just go through the levels and see what they would look like with different number of d orbitals, that number of d electrons. Okay, so T. Okay, T2 and E, and this would be a D1 electron configuration, one in the bottom. D2, we go up, up. D3, now we don't do any pairing for tetrahedral, so we go up, up, up. Okay, you can think about this however you want. You could think about that for tetrahedral, there's only a high spin form, however you want to think about this. But this is how the filling goes. We always jump up into the top set. D5. D6. So a similar thing happens that happened with octahedral. We go all up first, and then now we have to put one down, and the bottom is better than the top to pair. Okay, there's D7. Here's D9. And then finally D10. So yeah, this is what I wanted you all to look at, is just go through and fill these. So, you know, when you're doing it on a quiz or exam, it doesn't hit you as weird that you jump up here, that you've thought about it, that you've sat down and you've practiced all 10 of these. Another interesting thing to do, and we'll do this, this will be in a subsequent video, is so for 4 coordinate, the two geometries are tetrahedral, all of these are tetrahedral, and square planar. And you'll see when we do the comparison that in most of the cases, the tetrahedral and the square planar would have different numbers of unpaired electrons. So you'd be able to tell them apart by doing this sort of little sketch. One final thing to say here, the problem actually asked for the number of unpaired electrons, and so I've written that on each one of them. We just need to count all the boxes that have a single electron. So D1 has 1 unpaired, D2 has 2 unpaired, D3 has 3 unpaired, 4 unpaired, 5 unpaired. Then once we get past 5, we start having to pair things. And so this box is paired, and so we have just 1, 2, 3, 4 unpaired electrons. We add another electron that goes down at the bottom, so now we're left with just 3 unpaired, 2 unpaired, 1 unpaired, and finally D10 is no unpaired electrons left. And this, I guess, to give us our full symmetry, if we had the D0 electron configuration over here, it also is 0 unpaired electrons. So D0, no electrons, is no unpaired electrons. So we go 0, 1, 2, 3, 4, 5, 4, 3, 2, 1, 0.